Well, welcome back. Coming at you live again tonight from the Hill household here. And we're going to talk about graphing rational functions tonight. So let's get down these few short rules that we want to use anytime we graph these rational functions. All right, so number one, we always want to find any wholes. And in order to find wholes, we have to make sure we factor first. All right, second, we want to find any vertical and horizontal asymptotes. And we'll focus on that one in a minute. Third, any x and y intercepts. And then fourth, we'll plot a few points and we should be able to get the idea of our graph down. All right, so I just want to add a few more ideas before we actually dive into one here. Again, we already said we want to factor first. Okay, that's a no-brainer. Now, let's go get our wholes. How do you get a whole? Okay, well, if anything cancels, we know we have a whole. All right, so let's get that in our notes there. If anything cancels, we know we have a whole. Second, we need to get our asymptotes. Let's start with a vertical asymptote. Okay, and again, this is review. You should know the answer to this. If I want to get a vertical asymptote, I set my denominator equal to 0. Okay, and that will give me a vertical asymptote. If I want a horizontal asymptote, okay, now this is the tricky one. This is the one that bothers people sometimes. So I want to see a graph in your notebook here. All right, you should be able to rationalize this in your head. If you have a horizontal asymptote, so let's go ahead and draw one in. All right, now let's draw a function in that kind of goes out towards a horizontal asymptote. What you need to say to yourself is, what are your x values approaching? Okay, when you look at this graph, where are your x values going? Are they stopping or are your x values going forever? All right, let me say that again. Are you stopping or are your x values going forever? X values. All right, they go on forever. So this is the limit as x approaches infinity. Therefore, every time you want a horizontal asymptote, you are doing a limit as x approaches infinity, which we all know is the power fight. All right, so if you forget, you should be able to rationalize this out and draw a horizontal asymptote, draw your function in, and say, what is x doing? All right, let's talk intercepts. All right, if I want an x-intercept, okay, what does that mean? Again, you don't have to memorize anything. It's called common sense. Picture what it means to have an x-intercept. Okay, what value do you know about every time you hit the x-axis? Y equals 0. Okay, likewise, if you want a y-intercept, again, there's nothing to memorize, common sense. If you have a y value, every value there, what do you know for sure? X equals 0, and then obviously solve for the other variable. And then lastly, we said we're going to plot a few points and get the idea of the graph down. So before we dive into one, I want to go back. I got a little excited over these horizontal asymptotes. I want you to go back in your notes, and I want to add one more thing in there. Okay, now notice we said it's the limit as x approaches infinity. Now it doesn't just have to be positive infinity. All right, it could also be the limit as x approaches negative infinity. All right, my graph, and let's add this into your graph, your asymptote your asymptote would stay the same, but your function could head this direction. Okay, so in this time, x isn't approaching positive infinity, it's approaching negative infinity. Either way, it's a power fight, but be careful, it could be positive or negative infinity. All right, let's start with this nice rational function we have here. G of x equals x minus 1 all over x squared plus 4x plus 4. Okay, so you need to always say to yourself, factor first. So let's rewrite g of x here. Going with 2 and 2. All right, now nothing cancels, so let's just make a note off to the side. We have no wholes. Nothing cancels, and you're always finding wholes first. All right, so let's go get our vertical asymptotes. Okay, that is when we set our denominator equal to 0, when our fraction is undefined. So I'm setting x plus 2 and x plus 2 equal to 0, teeing it up, and I get x equals negative 2. I actually get it twice, but obviously there's only one there at negative 2. Okay, so I have a vertical asymptote at x equals negative 2. Let's go get our horizontal asymptote. Okay, this is my power fight. All right, now if it's easier to look at the original function for a power fight, that might make more sense. The biggest term on top is x, the biggest term on the bottom is x squared. That gets me a small over large, or y equals 0. Okay, again, that was small over large, and it's usually easiest to see in that cleaned up version. All right, now time for the intercepts. I think the y-intercept is easier, so I'm going to do that one first. A y-intercept meant x equals 0. So all I'm going to redo is substitute 0 into x. So I get 0 minus 1 all over my 0 squared plus 4 times 0 plus 4, negative 1/4. Okay, and again, that's my y-intercept. All right, so now we'll go get the x-intercept. This time I'm plugging 0 into y. Notice it's the opposite letter. Okay, so this time I'm saying 0 equals x minus 1 all over x squared plus 4x plus 4. Okay, so now, again, I want you to use common sense. If you have a fraction that's actually equal to 0, okay, what does that mean? How do you get 0 when you have a fraction? Do you have 0 divided by a number or a number divided by 0? How do you actually get 0 as an answer? Well, remember, if 0's on the bottom, it's undefined. That's not equal to 0. So when you set a fraction equal to 0, you're really just setting the top part equal, okay, because that's how a fraction equals 0, if the numerator is 0. So x minus 1 equals 0, x equals 1. All right, so I can label, this is the point 1, 0. I know I have that point. And I'm going to go back and actually label my y-intercept, that's 0, negative 1/4. All right, so I have 2 points to label on this graph. All right, so let's put this all together here. So what I've done is I've just rewritten my function and the things I know. You already have that in your notebook, and now it's time to graph it. All right, so what I want you to do is I want to get at least a couple tick marks on. Let's go 3 in each direction. And we'll graph this puppy. All right, so the first thing I know for sure is that I have a y-intercept at 0, negative 1/4. So let's check that off and plot that point. 0, negative 1/4. I have an x-intercept at 1, 0. Plot that point. No holes, that's fantastic. I don't have to worry about that. Horizontal asymptote at x equals negative 2. So here's negative 2. X equals, of course, is a vertical line. And then a horizontal asymptote at y equals 0. Okay, so that's, of course, a horizontal line at y equals 0. All right, now you might be bothered for a second, and I'm hoping not too bothered because we have talked about this. You have a point on an asymptote. Okay, now that is okay only because it's a horizontal asymptote. You are allowed to crash horizontal asymptotes, not vertical. Now you might be thinking, why the heck is that true? So let me just give you a brief explanation off to the side once again. The definition of a horizontal asymptote is it describes the end behavior. It tells me what the function is doing in the end. So if this function wanted to, it could go up and down a million times and then just kind of tail off at the end, okay, because it only describes what's happening at the end. I don't actually care what it does in the middle. So the definition of a horizontal asymptote is the limit as x approaches infinity, what happens at the end when x gets really big. So I can crash in the middle, that is okay. All right, we've got enough points to get half our graph drawn here. So I know I have to go through those 2 points, which means this is, notice this is below this asymptote and on this side, so it's just going to have to come close and hug that asymptote. Now this clearly is going to have to go above because I have to go through that point, so it's going to go above, but it's got to come back and hug the asymptote. Okay, it has to get closer and closer without touching at the end, towards positive infinity. Now something else that must be happening on this side of x equals negative 2. All right, and it's very simple to tell. All we're going to do is we're going to plug in the point negative 3. And if it's positive, it's going to land between these asymptotes. If it's negative, it's going to fall between these. I know it's not going to touch because we only had one x-intercept, and that was over here. All right, so let's carefully plug in negative 3. So g of negative 3, it's negative 3 minus 1 is negative 4. All over negative 3 squared is 9. 4 times negative 3 is negative 12 plus 4. So let's see, 9 plus 4 is 13 minus 12 is 1. So that gets me negative 4 over 1, or negative 4. That means at negative 3, negative 4, I have a point, which is right here, which tells me the rest of the graph is going to sit between these two asymptotes. All right, well, that leads us into our next example. So we have h of x equals 3x squared minus 12x minus 15 over x squared minus 3x minus 10. All right, the ball's in your court. We need to go get everything we need. We need holes, vertical asymptote, horizontal asymptote, x-intercept, y-intercept. Okay, pause it, work this out, see if you get what I get. So I'll see you in a few seconds. All right, we're back in action here. I'll show you what I did briefly. I pulled a 3 out in the numerator, refactored. Obviously, that's child's play. I canceled my x minus 5, so there's my work for my hole. I said x minus 5 then has to equal 0, therefore my hole is at x equals 5. Now I can be a little more specific about that hole. It's at 5 what? Okay, well, common sense says if you know the x value, how do you get the y value? Well, you just simply plug it in. So that hole should be at 3 times, let's see, 5 plus 1 is 6, over 5 plus 2 is 7. That's 18/7. So let's get the exact point of that hole. All right, here's the rest of my work. Vertical asymptote, set whatever's left in my denominator equal to 0. I got x equals -2. Make sure it says x equals. Horizontal asymptote is simply a power fight. I think sometimes it's easier to do it of the original, so I looked back here and did my power fight. So I got a y equals 3. Y-intercept, plug 0 into x. I got 3/2 for my y equals 3/2. X-intercept, plug 0 into y. And again, I want to stress if a fraction equals 0, okay, it's meaning the top equals 0. If the bottom equals 0, then you would be undefined. So again, when the fraction equals 0, it's the top equals 0. And hopefully you got x equals -1. All right, so I think we're ready to graph that bad boy. Let's see. Using all the information I have, I'm going to start with my vertical asymptote. Okay, we'll plot out -2. Here's my vertical asymptote. I should have a horizontal asymptote at 3. 1, 2, 3. Nice horizontal. Okay, plot some more points here. Looked like cross these off. We took care of that, took care of that. My y-intercept was 3/2, so I know I'm going a little bigger than 1. Okay, 3/2. Cross that off. My x-intercept was -1, so I know I'm crossing there. Check that off the list. And lastly, that hole. Okay, that hole is at 5, 18/7. All right, so I'm going to go out 5. 1, 2, 3, 4, 5. All right, remember, I just plugged it in to get the y value. All right, so 18 divided by 7. 7 times 2 is 14. 7 times 3 is 21. So I know what happens between 2 and 3. All right, so that's a key. This graph between 2 and 3, heights of 2 and 3, has to have a hole, and make sure you put a hole there. All right, so your graph has to hug the asymptotes. So on the left side of this dot, it better shoot down. Can't touch that. Okay, now I know it's not going to cross over, okay, because I know I have to hit that hole and come out the other side. All right, so don't go through the hole. There should be an open hole there. And then I just have to test a point. Something must be happening on this side. It's either going to be above or below. And that testing was very simple. Let's just take -3 and substitute it into the function. I'm going to have to scroll back here. Let's see. If I clean that function up, it was 3 times x plus 1 all over x plus 2. And I'm substituting in -3. -3 plus 2 on the bottom is -1. -3 plus 1 is -2. That gets me a -6 or a +6. So at -3, I should be at a height of +6, which puts me up here. So that tells me I'm going to squeeze in between those two asymptotes. All right, well, that's going to do it for us tonight. Make sure you have your vertical asymptotes, horizontal asymptotes, intercepts, and that power fight down. We'll see you tomorrow.